Chapter 9, Section 2 today. We're going to talk quadratic formula. So yesterday we worked on solving using square root properties and completing the square solving quadratics. Now today we're going to use the quadratic formula. So we factored, we've completed the square, used square root. Now we're going to use the quadratic formula. So we're not going to derive it. That's the first objective today. No, we're not going to do that. But we are going to solve several using the quadratic formula, and then we're going to use the discriminant to figure out exactly how many solutions they have as well. So let's get going. Derive. Looks fun, doesn't it? Here it is. Got all that? Great. Here it is. So here's the quadratic formula. You want to take some time, a couple seconds here to write this in your notes. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. There you go. Nice little song that you've probably heard somebody sing to you before with it. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's what your x value is going to equal using this quadratic formula. And again, this is just another way for us to solve quadratics, so x squared plus 2x plus 3 questions. Given that a can't be 0 in this, because if a was 0, then you divide by 0, you can't do that, so all that kind of fun stuff. Formula. So our first one is 4x squared minus 11x minus 3 equals 0. So the first thing I like to do is I like to list my a, b's, and c's. So my a value is 4, my b value is negative 11, and my c value is negative 3. So the formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So now we plug them in. So negative b, so the negative of negative 11 is 11, plus or minus the square root of negative 11 squared. So negative 11 squared minus 4 times negative 3, all divided by 2 times 4. Okay, so that's 11. Plus or minus the square root. 11 squared is 121. We've got two minuses, so this is going to be a plus. 4 times 4 times 3, 16, 48. All of that divided by 8. So that's 11 plus or minus the square root of 169 divided by 8. So that's 11 plus or minus the square root of 169 is 13 divided by 8. So we've got two solutions. 11 plus 13 divided by 8, which is 3. And 11 minus 13 divided by 8, which is negative 2/4, 2/8, which is negative 1/4. So there are your two solutions. You're going to have two solutions. You've got to do the 11 plus 13 divided by 8 and 11 minus 13 divided by 8. Okay, so there's one example of the quadratic formula. Here's their explanation of it. Hopefully we got the same answers, and we did. So the next one, we've got 2x squared plus 19 equals 14x. So in this case, it's not equal to 0. So anytime you're using the quadratic formula, step 1 always has to be to set it equal to 0. 1, make sure it's quadratic, and then set it equal to 0. So we're going to move the 14x to the left-hand side. So this would be 2x squared minus 14x plus 19 equals 0. I can list my a value is 2, my b value is negative 14, c value is 19. Okay, I've got this all in my head, so I'm not going to rewrite that. So x is equal to negative b, so negative b is 14, plus or minus the square root of b squared, so negative 14 squared minus 4 times a times c. All of that over 2 times a. Okay, so we're going to simplify. So that's 14 plus or minus the square root of 14, and I'm just going to type it in how I see it. Inside parentheses, negative 14 squared minus 4, and then I'm going to put a parentheses around the 2 and a parentheses around the 19. That gives me 44. All over 2 times 2 is 4. Now we continue to simplify. So that's 14 plus or minus 44. Got to do it's 4 times 11, which is 2 times 2 times 11. So that's 2 radical 11 over 4. So then this could be simplified a little bit. 2 goes into each of them. So it could be 7 plus or minus radical 11 over 2. And that is a perfectly legit way to write the answer. Okay? Actually, I'd be happy with this too. So make sure you simplify if you've got radicals. Just like we've been doing all along. It's really no different than what we've been doing kind of all along here. Okay? And the solutions that we get. One that's in this form, I'm not going to do the whole thing, because we got the quadratic formula kind of down, but just remember, if you've got x plus 5 times x plus 1, we need to turn it into an x squared, so you're going to FOIL this first. So you go x squared plus x plus 5x plus 5 equals 10x. So that's x squared plus 6x plus 5 equals 10x, and then move the 10 to the other side. So x squared minus 4x plus 5 equals 0. And then you can go ahead and use the quadratic formula on that one. Okay, but you got to get it into the 4x squared form first. So it's in what we call standard form. Okay. And then they went ahead and did the quadratic formula with that. And notice in this one, they got i's, that's okay. They got plus 4 plus or minus the square root of negative 4. Remember, that's 2i. And that's okay. There's nothing wrong with getting complex numbers in there. Those happen all the time. So there's nothing wrong with that. Complex numbers aren't bad things. Okay? Now, essentially, what's happening when you're doing these is we're graphing parabolas is really what these look like. So when we're talking about finding types of solutions, there are 3 different solutions that you could have. When you're talking about solutions, what you're really talking about is when these graphs, these parabolas cross the x-axis. So you can have 0 solutions if it's like above the x-axis or below the x-axis, so it doesn't touch it, that's 0 solutions. You can have 1 solution if it comes down and smacks the x-axis and bounces back up. Or you can have 2 solutions when it goes through the x-axis and comes back around and hits it in 2 spots. And we can use what we call the determinant, or the discriminant, sorry, to find that. So there's another thing right in there that I want you to list. The discriminant, that should be in your notes. The discriminant of ax squared plus bx plus c is b squared minus 4ac. That's called the discriminant. Now, if the discriminant is positive, meaning it's greater than 0, there are 2 solutions. Okay. If it's greater than 0, there are 2 rational solutions. Okay. Either way. It can be rational, it can be a nice number, or irrational, it can be a bad number. But if it's positive, meaning it's greater than 0, and you just do that part, underneath, what's really underneath the radical, b squared minus 4ac. If that's positive, greater than 0, you've got 2 solutions. If it's 0, you've got 1 solution, rational solution. And if it's negative, it's no solutions or 2 non-real complex solutions, meaning you're going to have an I in there. So you'd have the negative square root. So that has no solutions or no real solutions, or 2 non-real complex solutions. Is kind of what that means. I guess that's down again. So for example, if we're going to find each discriminant and use it to predict the number and types of solutions. So when we're doing and we're just finding the discriminant, all we care about is the A, B, and C, so they've already listed that for us. So if we're finding the discriminant of 10x squared minus x minus 2, now we're going to go ahead and do the b squared minus 4ac and see what that turns out to be. So b squared, so negative 1 squared minus 4 times 10 times negative 2. So negative 1 squared is 1 minus 4 times 10 is, so we've got essentially negative 4 times that, that's 80. So this would be plus 80. So this is equal to 81. Since 81 is greater than 0, there are two real solutions to this. And it's just following and finding that discriminant. So there are two, and they say rational solutions. And on your assignment today, it's going to say, are there two rational solutions or two irrational solutions? The way you know if it's rational or irrational is 81 is a perfect square, so they're rational. If it was like the square root of 20, which you don't know what's a decimal, that's irrational. Okay, so that's how you tell the difference between rational solutions and irrational solutions. Okay. The next two in here, we're going to define the discriminants of them. So again, you have to set it equal to 0 first when you're finding these. So that's 3x squared minus x minus 7 equals 0. So my a value is 3, my b value is negative 1, and my c value is negative 7. We're just interested in the discriminant, so b squared, so negative 1 squared minus 4 times 3 times negative 7. So that's 1 minus and a minus is going to give me plus 4 times 3 times 7 is 84. That's 85. I don't know the square root of 85. So this is going to be two irrational solutions. So two distinct irrational solutions. For the second one over here, again, you got to set it equal to 0 first. Now we've got our a value of 16, our b value of negative 40, and our c value of 25. So negative 40 squared minus 4 times 16 times 25. 40 squared is a big number. 40 squared is 1600 minus 4 times 16 times 25. That's 1600. So 0 equals 0. So since it's 0 equals 0, we said if the discriminant was 0, then there was one rational solution. So there would be one rational solution for that one. Okay, and there's just of them as well. And you could have one that have exactly one solution, and so on and so forth. And we're not going to really work on that type of question at all. We're just going to look and see how many solutions that they have. So there is section 9.2, using the quadratic formula and the discriminant to find out how many solutions there are.